thank HDS for giving me the opportunity to come and give this talk, and Scott Thornton for pestering me until I agreed to do it. It is a nice opportunity to do it. The last time I talked here, I used a slide carousel, so that should tell you how long it's been, since the Pleistocene, I think. So I'm going to hopefully make this worth everybody's while. I will apologize in advance if it seems to go a little bit long. I'm going to try to skate through as much of it as quickly as possible, but not too rapidly. My co-author, Francis Innes, isn't here tonight. I understand completely why, because he lives in the woodlands. But this is sort of a derivation of a talk that we did at the AAPG GTW in Port of Spain earlier this year. This one substantially fleshed out by comparison to the one we did in Port of Spain. So there's a lot of good stuff in here, at least I hope. And hopefully we'll be able to lead you sort of through this story. Doesn't plunge directly into the Caribbean, but we get there over time. So what are we going to talk about? Well, really what we're talking about here is what is the Cretaceous play? Or when people talk about the Cretaceous play, what are they talking about, and what are the variants of the Cretaceous play as it's currently being used and worked in the industry, because it means different things to different people. There's a part of the Cretaceous play that's called the fan channel play. Okay, submarine fans, submarine channels, as you might expect. And we're going to talk about where that's working and why that's working, because it doesn't work everywhere, as you can well imagine. But we'll show you some examples from equatorial Africa, from northeastern South America, and we'll stick our finger in the Caribbean at Trinidad for this part of the play. And I'll talk about some future considerations or things that we should consider if we're chasing these types of plays in the region. The second part of this will be sort of a brief historical overview of exploration in the Caribbean, focusing primarily on recent activity, which means since 2000. This sort of historical overview will start in about 1970, but I'm going to cram 1970 to 2000 into about 2 minutes of conversation. And then I'll give you some summary thoughts for what they're worth. Okay. So what's the Cretaceous play? Well, right now, as we see it, it's been extrapolated or extended from what we would classically call the West Africa Transform Margin play, which got its roots in Ghana with the discovery of the giant Jubilee field complex, Cosmos, Anadarko, and Telo, the primary participants there. And this is where everybody really started talking about the Cretaceous and thinking about the Cretaceous in ways that we haven't done for quite a long time. Right now, though, the focus is on anything that's Cretaceous. And it really is anything. And this is what's causing problems a little bit now as we try and take this play or the play concept to other areas. And it really doesn't even matter what petroleum system. Generally, or classically, it's the Cretaceous petroleum system, or at least a Cretaceous petroleum system. And now it involves the Jurassic and God knows what else. So it's not strictly defined the way it's used now, the way it was classically defined and discovered. The traps can be stratigraphic, structural, or a combination thereof, which means it could be anything. They can be salt-related or not, and they could be sandstones or limestones. So basically, if it wasn't the Cretaceous, it could be anything. And that's where we have a problem, when we try and extrapolate it to what it really came from. So where'd it come from? Okay, well, there's a lot of verbiage up on here. I'm going to try to blast through it, because really the concept is very simple. The transform margin play really consists of a series of upper Cretaceous deep water slope and basin floor fans and channels, which is the deep water component of the talk that we really want to know about. They mostly are stratigraphic. Some have a structural assist, but they're generally stratigraphic traps. And they're being explored right now as we speak along the equatorial margins of both Africa and South America in a huge way in South America right now. And since 2000, there have been more than 100 wells drilled in the play, and Pan Atlantic and its predecessor company Vanco participated in about 10% of those wells. It doesn't seem like a lot, but you learn a lot by drilling a lot of dry holes. And the company has not been as successful as we would like to have been, and there's a reason for that, and I hope to show you later. So where is it successful? Well, generally it's been successful only in 1 or 2 places. There are only 2 commercial developments currently underway, although there are several considered. The first, of course, is Jubilee, which a lot of people have heard of. That's the Telo, Cosmos, Anadarko partnership. It's the biggest field in the trend, 700 million barrels recoverable depending on which of the companies you talk to, but that's generally the case. They also have the 10 complex, as you can see the names there, which will go into commercial development very soon. I think the FEED studies are done and they've already ordered the FPSO and it's about ready to go. It's about 360 million barrels. So between those 2 discoveries, you're talking about 90% or so of the discovered reserves resource in the play, which is really kind of disturbing when you think that more than 100 wells have been drilled. What we're talking about are wells that average about $100 million each. So in general, we're talking over $10 billion of expenses in 2 commercial developments. It's a pretty significant statistic. There will be more. We know there will be more because people have declared the commerciality of several others. The MTA development, which is just adjacent to Jubilee, which you'll see on a map in a second. ENI's Sankofa discovery, they declared commerciality there, although I don't know that a final commercial decision's been made. Hess has Pecan and its sort of cluster of satellites around it. I don't know if they've decided to do a commercial development. I know they were doing pre-dev work the last time I talked to people over there. And in Nigeria, there are a couple of interesting things going on. Aje Field, which looks like it's going to development, although it's been in fits and starts for a long time. And Ogo, which nobody really knows very much about other than what's come out in the public literature. The discovery, if you believe what's been written about it, is enormous and could be as large as Jubilee. It's on something really unique in Nigeria, and I think what you get, or the impression you get from looking at this, is it's really working in 2 places right now, potentially 2 places. Ghana in a big way, and maybe Nigeria. But that doesn't mean that hydrocarbons haven't been found elsewhere. They've been found, well, in most of the countries in the equatorial margin. Guinea, in addition to Ghana, Sierra Leone, Liberia, Cote d'Ivoire, Benin, and Equatorial Guinea, which is a little bit different and slightly older and has its Okume and Seba developments going on. So it's been fairly successful, but in a very limited way. And of course, in South America, everybody knows there have been some high-profile discoveries made in Brazil in the Ceará Basin, for example. And there's been a lot of activity, certainly in the last bid round in 2014, in the equatorial margin, adjacent to French Guiana, and we'll talk about that in a little while. And then in Guyana and Trinidad, of course, there are hydrocarbons. But the issue is commercial hydrocarbons. And what really affects the commerciality of these things? Well, the technical side, first of all. So you need some access to charge. That's sort of a no-brainer, right? You would think, but it becomes very difficult in these systems. Trap definition is another one that seems to be lacking from time to time in what people do, and I'll tell you why in a second, because there's so many potential leak points in these things. And it's the leak points that really get you in 3 dimensions. Reservoir presence and deliverability, well, you know, everybody says, yeah, you got to have a reservoir. It makes sense, right? But deliverability is really the key in these systems, because the older you get, the worse the deliverability seems to be. So you may have a significant reservoir package and not be able to produce any of it, or at least in a commercial amount. And then hydrocarbon phase. Well, too much gas is not a good thing out here, and I'll talk about that in just a second. And we've had very spotty success using seismic, whether it be AVO and attribute work, rock properties work, whatever. There was initial good success using it, and then everybody said, well, this is all we need to look for, so if we find that, then we will have a high chance of hitting a decent well. And it's led people to drill a lot of dry holes because they forgot about the other 3 bullets. They just relied on the AVO and attribute work and didn't really worry about how many leak points there were in the traps. So there's been a lot of money spent doing that. And I did mention gas. Gas is bad. Just ask the Jubilee partners right now who are stuck trying to upscale that project, and they can't get their gas pipeline commissioned because there's no place to put it right now. They need to sell it someplace. They don't want to re-inject it, and they can't flare it. So too much gas, bad. All right, so it's a little blurry. I apologize. I stole this from an investor presentation that Cosmos put out earlier this year, and you'll see that I steal a lot of stuff from the public access in this presentation, and it keeps me from having to show a lot of proprietary stuff, which is good. So you'll forgive me if I do finger pointing. I forgot to bring a pointer, but these are the two big discoveries we talked about in Ghana, the 10 fields to the west there, to the left, and Jubilee, which is in the white outline there to the right, and you see the MTA series of fields, which will also go into development. And there's two things that I want to point out here. First, they're very close to each other. And the geographic proximity means that fields that might ordinarily not be commercial on a standalone basis can be commercial in a hub and spoke or an extended FPSO program just because they're geographically close to each other and you can reach them. If you took Enyenra or Ntome and you put it in the middle of nowhere, it probably would not be commercial. But the fact that they're so close together makes it really worthwhile. The other thing I want to point out is that red line that sits there, which I added. That represents about 40 kilometers, more or less. And you'll see that line on several slides as we go through. And why is that important? That 40, it'll be actually 40 to 50, but right now that 40 kilometers represents the distance from the paleo shelf margin to the last oil discovery that you see in a given place. And why is that important? Well, I'm going to tell you, I'll tell you now and I'll tell you again later, that 40 kilometers is extremely important in terms of finding commercial oil. That more than 90% of all the discoveries of oil in the trend and commercial discoveries made in the play are within this 40 to 50 kilometers down depositional dip. And in fact, the bulk of those are actually within 25 kilometers of depositional dip. It really becomes important, and then we start talking about trap integrity and reservoir deliverability and things like that and how they apply. So let's cruise through these. All right, so this was borrowed from Anadarko. Thankfully, they showed a couple of nice cross-section cartoons here, and you can see on the top one there, well, the top and the bottom on the left are essentially dip cross-sections going from the paleo shelf margin down slope to the slope fan channel complex. They're developed primarily within the Turonian. The Turonian works best. It has the best reservoir quality and has the best access to charge of any of the units in the Cretaceous. There are some pays in orange there on the left in the Campanian. The Campanian generally doesn't work outside of this area, and we'll talk about why in a minute. But you can see there's a whole lot of little geobodies in different places, some in yellow, some in orange. And if you look at the sort of strike cross-section across these complexes, you can see they look like a series of nested or interlinked complexes, both in the Turonian and in the Campanian. And really, the slide doesn't do the seismic justice. These areas, as many of you who've worked these things know, these areas have large numbers of fan channel complexes that are down cutting into each other and overlapping each other. They anastomose and they cross each other in various areas. It's really a spaghetti mess of these things. And the young ones, the Campanian ones and the Maastrichtian ones, down cut even to the Albion in some places. They're really ferocious in terms of cannibalizing what came before. So if you are exploring for Turonian reservoirs, what you don't want to see are deep cutting Campanian fan channel systems. They're usually bad in 3 dimensions. We'll talk about why. Okay, so this is a map that I generated out of IHS. It shows several different things on here. We're not going to talk about all of them, But just suffice to say, all the green callouts there represent wells that have found oil. And this is in the area from Sierra Leone to Liberia and western Cote d'Ivoire. And what you note is a lot of wells have encountered oil, but there are no commercial discoveries here. Nothing been declared commercial up to this point. That's not necessarily a bad thing. Maybe we're just waiting for more wells. The ones in blue are dead dry holes, water only. And the ones in white, as you can see there's some white dots in there, are wells to be drilled either this year or next year. And you can see there's quite a few actually. So drilling hasn't stopped out here and the interest hasn't died, whether it should or not. The most recent well drilled was Gosh Turn in sort of the center of the map there near Carmine Deep. This is in Block 12 in Liberia that Chevron just drilled, TD'd. Chevron doesn't talk much about what they do. So we don't know very much about Carmine Deep or Nighthawk either, but we do know that so far they haven't drilled a commercial discovery because they haven't declared one, and neither has the Liberia government for that matter. But a lot of wells have oil. The one that looks like it might have a chance to be commercial, based on what we know about it right now, is right here in the lower right, Saphir, which was drilled by Total earlier this year, and has 40 meters of net oil pay in it, although we don't know if that's 40 meters of 1 meter sands or 40 meters in a big thick section. And so for the people who reacted, you understand the problem. 40 meters of pay doesn't mean commercial. It could mean 40 individual sands, which are non-commercial. So that becomes really the key as we go forward here. So let's take a little bit of focused look now at Liberia, so you can see how other people are seeing this. This isn't just me saying this. So this again is borrowed from Anadarko. They're very generous in showing what they think. In 2011, this was their view of things. They had not drilled Montserrado at that time. Montserrado was a discovery, non-commercial. Venus had been drilled and Mercury had been drilled, both discoveries, both non-commercial. But you see these things are shown as a series of overlapping or stacked fan channel complexes. And if you look, you can see my red arrow up there. It's got a little green one pointing to it, 40 kilometers. And all of the discoveries that have been made in Liberia so far are within this 40 to 50 kilometers from depositional dip down the paleo shelf margin. This sort of is the reason why things don't always work out the way you want. In the lower part down here, you can see their cross-section, their sort of cartoon cross-section across the 10 complex. It goes from 10 to Jubilee. And you remember there were nested Campanian channels, and then the purple right there is the Turonian section, and you know, you want that all to work out right. The upper cross-section there, again, is a strike section across these systems and shows Enyenra to Jubilee for scale. And look at the scale we're talking about. Enyenra to Jubilee is less than a third, it's really less than a quarter of the distance that we're talking about here, and we're expecting the whole thing to work just like it did in Ghana. And Anadarko was one of the key players in Jubilee, so they should have the insight. Unfortunately, they have not drilled a commercial well yet. Doesn't mean they won't, but they haven't, because it hasn't really worked out this way. So let's take a quick look at what somebody else thinks. So this is from a couple of African Petroleum investor presentations, and the inset map up to the upper right there is one that they published or made public, I think in 2012. And in that particular one, you can see it's a hornet's nest of little things laying over the top of each other. And imagine these things in 3 dimensions, down-cutting each other, how complex the trapping points and contacts are going to be in terms of where thief zones exist and where they don't. Can you actually figure out that you can map all the potential leak points up there? That's really scary. So what they did is say, we're going to throw out the ones that we can't do that with, and we're going to just do those. So the larger map is what they ended up actually drilling on. And you see Narine, which actually was a good well, looked like it would be potentially commercial, which was followed up by Bee Eater, which has a large oil column that doesn't look like it's producible because it's tight. It's really low perm. And there's our sort of red 40-kilometer line. And it makes you wonder, though, about the things that are basinward of the 40-kilometer line, whether those are going to work or whether they're not going to work. And there's sort of a split view there. This is what Narine actually looks like on seismic. Again, African Petroleum was nice enough to give us the seismic line so we could see what it really looks like, because I didn't have any seismic across this. And you see it sitting on a sort of little bit of an uplifted pre-rift relic topography, and the Sin-Rift section, which has a source in it, mostly Albion source, is sitting just to the right of that, actually to the northeast, if you're looking at orientation direction. So this is northeast southwest. And you can see in the yellow there all the off-lapping fans. They come to a pinch point right about at the top of that basement high. And the ultimate pinch point of this is up on the paleo slope, the upper paleo slope, where there's a bypass zone. And that bypass zone is really important for the genesis of the play, because you need some way to stop the oil from going from the basin all the way up. And if it's not pinching out before you get up on the shelf, well, it just goes up on the shelf and gets dissipated into heaven knows what. But right now, this looked pretty good. The problem, of course, is that as a standalone, it's a very small feature. And unless these things in the basin work, it's probably never going to be commercial. So nobody's drilled those things down in the basin yet, and we don't know if they work or they don't work. This is a little crossplot that I put together of what you would call discoveries. Now, discoveries are things that have found oil into play, and this is only the West African part of it. This doesn't take in the South American part. And on the y-axis are sort of estimated or reported recoverable reserves in millions of barrels equivalent. So you can see it goes from 0 to 800, really about 700 is about where we stop. And then the estimated distance in kilometers from the paleo shelf margin down to where the lower part of the oil accumulation is known, from 0 to 50 kilometers. And lo and behold, there's a gigantic grouping in this cluster, certainly from 0 to 40, so on our red bar, sort of works. But as I said at the outset, most of them are from about 0 to 25 kilometers down the paleo shelf slope. And right now, this is a nice coincidence. I don't know if it's more than coincidence, but it is a nice coincidence, and it might be something to keep in mind. The only thing here, and you can see there are a couple of outliers sort of near the 50, is that there are some discoveries, and I'm not going to name names out here, but there are some discoveries that are really quite a distance out there. And it may be that as we move this play out into the basin floor part of the setting, there will be some further out than what I'm showing. The big problem is in this play that the further out you get towards the basin floor, the deeper the water. And now we're talking nearly 3,000 meters in places. So there's an economic limit and a technological limit whereby this won't make any sense. But right now, this is the picture we get from the limited number of oil discoveries or hydrocarbon discoveries that we've had. So if I wanted to make some observations, what would I say? Well, this is what I'd say it would take for this play to work, based on observations of everything we've seen. You really can't have much structural deformation in terms of secondary folding or faulting. And why is that? Because you're breaching traps. And if you breach traps in this thing, it's very easy to get up into these shallower down-cutting fan systems and leak everything off. Now, in some places, these systems have fault terminations, and that might work. Jubilee is one of those where it has a fault termination, but we're not really sure whether the faults play a role in the trap or not. The parties who have done the development certainly know. I don't know. I can't tell from that, because Teak Field, which is just up depositional dip from it, is also charged. Regardless of that, you need those traps to be clearly defined, and especially because you've got multiple seals and trapping points that are going to be required to generate a large column. You know, when I said, well, you know, the Total well may have 40 meters and 40 different sands, I was sort of making a joke to a point, but we personally have been part of wells where that isn't a joke, that's the reality. And one of the reasons why this happens is because of all these multiple leak points, you're not able to build a large hydrocarbon column or a significant head, because it'll either blow through an ineffective seal or it will just leak up into one of these downcutting systems. So unless you know where all the leak points are, you don't know whether you've really got a commercial accumulation in place or not. And even after one well, as they found out in Narine, you're not really sure. Direct access to charge and charge focus, obviously those are really important for anything that you do. But when you complicate the migration pathways, you allow for more thief zones in 3D. And we're going to talk a little bit about that in terms of how now the Cretaceous play is starting to be exported into other areas, including the Caribbean, which is where we're headed with this. And obviously you need sand-dominated river systems with high maturity sands. We all would like that. But what we've seen in this 0 to 40 or 50 kilometers of depositional dip from the paleoshelf margin is there is an optimum distance where deliverability will impact commercial rates and column heights as well. So it's great to have a gigantic column of sand, and we've drilled wells that have huge amounts of sand in the Cenomanian and the Albion, but you can't flow anything out of them. They're tight as a tick. So is this all just coincidence, or is there some correlation here between all these things? Well, most of the commercial, or at least the pre-commercial discoveries, have been made in that magical 40 to 50 kilometers down the paleoshelf margin, or down from the paleoshelf margin. And as I showed in the previous diagram, the vast majority of those are within 25 kilometers. There are a couple of exceptions. I'm hoping at some point there will be more exceptions, because right now, if we describe the play this way, I can tell you where every single potential well will work and where it won't work. And that's not something anybody should be able to do from a podium in a dinner meeting. You should be able to have the data and really work the heck out of it and understand it. But right now, if you show me where your well location is, I can tell you whether it's got a chance or not. As we mentioned, the Turonian works best. Hands down, it is what you want to find, but only when those other things really work, because people have drilled Turonian traps both in Cote d'Ivoire and in Ghana that have not worked, and in fact have been disastrous failures because they were based exclusively on seismic data, whether it be the AVO or the attribute data. So younger and older units work only under special circumstances. We've seen the Campanian works in Ghana in certain places. In other places it doesn't work in Ghana, and I submit the Campanian most everywhere else won't work. There's just too much sand. It's such a robust sand-rich system that there are too many leak points in 3 dimensions. I don't think we're going to find too many commercial discoveries in the Campanian. And the flip side is true for the Albion Cenomanian. Tons of sand, but tons of impermeable sand, which you might as well just find shale for, as good as it is for you. So the $1 million or the $1 billion question for you then is, can the play work anywhere else? So like Central North Atlantic, Northern South America, and the Caribbean. Let's take a look. All right, so I'm not picking on Cosmos, I promise. This is another slide from one of their investor presentations, and I'll point out, if you can't see, it's a little bit blurry, but I'll point out in white there it says, to quote, export of core Cretaceous theme, tying back to Ghana, which is the big red dot there. And where are they taking that? Well, they're going up to Morocco and Mauritania. Well, Mauritania sort of works with Chinguetti, but it's kind of a special case. But they're taking it up into northern Morocco, all the way to Ireland, and also into northern South America. So what are my concerns when I look at something like this? Well, they're pretty clear. You're complicating reservoir architecture and geometry by taking it outside of a place where it was originally defined and just assuming that based on the way it looks, it's going to work. And especially in the areas where there's salt, it's not the same. Geometries change a lot. Reservoir deliverability is going to be an issue because you start draining carbonate platforms, you're going to get a lot of metastable stuff in the system, and diagenetically, you're not making things better. Trap and seal integrity are impacted. Anytime you've got salt involved and salt is still moving, this is not a good thing for maintaining the sanctity of these traps, which have multiple leak points, as we discussed. Charge access and focus is always different, and especially as we go further to the north, because we're now separating vertically and laterally your reservoir target from your source, which is in the Jurassic. And the more vertical separation, or the more temporal separation you get, the more complicated the system gets, which leads to sort of my last bullet there, which is the overall play and prospect risk is not going in the right direction. It's actually going up instead of going down. So I'm not saying this is a bad idea, but what I am saying is that this isn't making risk go down doing it like this. And lest you think that I'm making this stuff up, again, you know, I'm just taking from Cosmos' presentation from earlier in the year. You see the sort of white looking stuff down in the lower inset map are salt diapirs. And they drilled the flank of one of these things with this well, Fumasaka 1, or the FA, the Eagle Prospect. And you can see there's a salt diapir there, sort of in the light color, and their lower Cretaceous target zone. This is a pre-drill slide, by the way, or pre-TD slide. Well, lower Cretaceous was the target, not the upper Cretaceous. So the lower Cretaceous, which you already know has some reservoir complications to it, was their target. That's interesting. And we do know that what the result of the well is. The well was a non-commercial well, and it did have oil shows at the bottom, but it is plugged and abandoned essentially as a dry hole.
I'll keep on talking. Let me find the PowerPoint.
Oh, okay. Well, we're low.
It's okay.
Okay. So where else would you do it? Would you take it to the Porcupine Basin? I don't know. On the lower left there is an inset that they put in from Ghana, which shows the transition from Jubilee to teak again. And interestingly enough, that geometry is really what they're looking at. So when they look at the margins of the Porcupine Basin, they're only looking at geometry. And that's how they want to make the play. So I would be concerned if it was me. Does it merit a well? Maybe it does. Maybe it will work, and maybe it will be just an absolute play-opening, fantastic thing to do. But I'm not sure that risk is being correctly accounted for there. So now we flip over to the Caribbean, or at least in this slide, the Proto Caribbean. Go ahead.
Well, I don't know where to put it. Let's see. Maybe in the back, huh?
Well, I guess it's possible.
It's possible. I think that looks like it right there. Okay.
Okie dokie. Well, we'll see. We'll see how long it lasts.
It'll last.
Okay. So this GDE goes from late Cenimanian to Turonian. We published this in an AAPG spec pub. It seems like 100 years ago now. It was in 2003, so it's old, and I apologize for it being old. But essentially, it captures what we think is worthwhile to note about this. So you look at the Proto Caribbean and you say, well, okay, where should the deep water reservoirs be? Well, my answer is there aren't any, or at least not any you really want to go after. There aren't any major river systems draining off northwestern South America in the Cenimanian Turonian. They're just not there. You're actually getting source rock deposition, which is great, but you don't have a lot of river systems. The rivers are confined to northeastern South America, sort of from the far eastern part of Venezuela into Trinidad, Suriname, the Guianas, and then down towards Brazil. So that's where the sands are, that's where your potential reservoirs are, and so that's where you're going to see the same system operating. And lo and behold, it did. It did operate, and it did work. Everybody's heard about Zaius now. This was the play opener in French Guiana, caused an enormous frenzy, a feeding frenzy actually in Suriname, which we'll talk about in just a second. And why? Well, the early estimates off of Telo's website at the time said that the P10 recoverable resource should be about 700 million barrels. And remember, Telo is in on Jubilee. They were there, they were part of the thing, and they came out in their operated well, the only one they actually operated, and they found the big accumulation with the first well. Really, really good. But as we know, sometimes finding the big accumulation with the first well has drawbacks, which means you got to drill an appraisal to know whether you're commercial. And in fact, all the follow-up wells that have been drilled out here are either dry holes or non-commercial. And That's a really sad story, and I don't personally know whether the singulated fan system, which is what this is going to work on a commercial basis at this point. Certainly there's a lot of head scratching and soul searching going on now in terms of the commerciality of this thing. So what does that mean for anything else? Well, you can see I've got my little 40-kilometer line there in the lower right part of that complex of wells, and there's another one, but it's not 40, it's actually 100. So why do I have 100 up there in Block 47 in Suriname? Well, I'll show you. This is another GDE that we published in the same paper, and those sort of blobs coming out there. The blue line represents the drowned shelf margin, and this is a little broader time period, Cenomanian to Antonian. On the shelf, there are a lot of wells with sand, and that sand is all going that way. It's all going out to deep water. And you'll see there's 6 of these things, and if you go from right to left, the second one goes through Block 47 in Suriname. And it's actually confined in a submarine canyon, and looks quite interesting. They all link back to sources of sand that are very well known in these wells on the shelf. And seismically, this is what it looks like. This is a 2D line that, we shot when I was with Burlington. And in fact, we shot a big survey out here. Burlington, Total, Shell, KNOC had all of this Aqua Torre under license at one time, and we let it go without drilling a well. This was 1999, and I'm not sure if you all remember, but oil was about $12 a barrel in 1999, and nobody was drilling $200 million wells in 1999. Just wasn't going to happen. So sadly enough, we let the whole thing go. This is a reprocessed version. The 3D that's shot out here now is much more spectacular, which I cannot show you, but I'll show you a product of the 3D. And what you see in the canyon system are multiple fans sort of stacked on top of each other, and as you get towards the critical trapping point, there are some nice faults. They look very much like Jubilee in terms of where the faults intersect the critical trap point. But these things all truncate out on the slope anyway, so this one I really like. I think this one could work. It's planned to be drilled by Telo, who are the operators, in 2015. They're going to drill this well called Voltsberg. When they've done it, they've done pretty much what I've done. They've got 2 significant fan packages in there, the Voltsberg stuff and the, I can't even remember what it is, the Goliathberg stuff that's up above it. And within those are a lot of different geobodies that they've mapped as potential targets, and they're going to go down and test that. What kind of volumes we're talking about, we don't know. The up-dip trap is still a risk because you don't really know if it's going to work. Lateral seals, again, are still going to be a risk, but my biggest concern here is actually reservoir deliverability, because that platform that these sands are draining off of was full of carbonates in the Albion. It was a very significant carbonate platform, and so through Cenomanian and Turonian, you could have quite a bit of admixed carbonate in this, and I'm concerned about the reservoir quality. But I like this play. I think it might work. So that brings us to Trinidad, which is sort of where we're going to end up, and then jump into a review of the Caribbean. And for those of you who've worked Trinidad, congratulations, you have my sympathy. It's a very difficult place to work for geologists. They've called it the graveyard of geologists. That's what the Trinidadians call it, and for a lot of reasons, not the least of which is that it's stratigraphically and structurally really complicated. And what did we say about Cretaceous reservoirs or the Cretaceous play? Structural complication is bad, and this is a poster child for a structural complication. The fan systems that are probably draining off the South American margin here can be mapped in any different way you'd like. I've done it in, I'm a lumper and not a splitter, but you could be a splitter if you want. There are probably anastomosing and overlapping systems all through here, but it's been drilled, as opposed to some of these other places, it's been drilled onshore and even offshore in a number of wells. And that's a good thing because we know that sand is in the system. But it's not very helpful because it's been crushed to such an extent that we don't really know where these things originally were. Now, this is a seismic line that I got from Petrotrin some years ago. This was actually an interpretation we did 15 years ago when we were looking at these things, and this is before Jubilee and all of this stuff. And it's flattened on the on the base of the Oligocene detachment, which is essentially decouples from the older rocks right on the top of the Cretaceous, or very close to the top of the Cretaceous. The hard events there are probably lime cemented sands or marls, and the transparent stuff are the overlapping fan channel bodies. This has not been drilled. Now, it has a lot less structural complication than anything else I've seen in Trinidad, but it's still Trinidad, and it means that these things leak. And where it has been drilled in Trinidad, there are no commercial accumulations. There's hydrocarbons in the sands, but there are no commercial accumulations. Exxon found this out with Rocky Palace and the other two wells. There's hydrocarbons in the system, there's plenty of sands, but maintaining trap integrity is really difficult. So here's an example from Diablo. I've shown this at a couple of meetings, so forgive me if you've seen it before. But the Diablo 34, which is to the west of where that seismic line is, penetrated one lobe of that system. And you can see the gamma, there's some very blocky sands, pretty significant sands, well over 100, 200 feet thick in some cases. But most of the stuff is just residual hydrocarbon. There are the non-reservoir units like the channel lag conglomerates, and then there are these nice fine channel sandstones, fine to medium sands, and they were oil impregnated. When I first looked at this a long time ago, even though the well was drilled in the 1960s, it still smelled of oil, but it was a blown trap. So you can put oil into the sands, you can trap the oil, but if you disturb it again structurally, all bets are off, because these systems, again, even when you can't see them, you know from analogs, they're overlapping and downcutting each other, and as soon as you break through the seal, you're up into the rest of the stuff. So in this part of the Caribbean, what would I say if I was asked, where would you go? Well, this is sort of an arm wave of where we thought these systems might have extended. You know, modern fans can go for hundreds of miles, but we already know that the sweet spot in this play is within 40 to 50 kilometers of the shelf margin. Well, guess what? In Trinidad, it's in the crush zone. So that's not good. So the only way this is going to work in the southeastern part of the Caribbean is if you go north, my friends, towards Barbados. Now, obviously, you can't go all the way. If you, I don't know if they've got it here, but if you talk to the MCG guys, they will show you some really neat seismic south of Barbados in the Tobago Trough. And there's some stuff down there, deep reflectors, much deeper than all the tertiary stuff, that may or may not have some of these things in it. I don't know. It's going to be a real grab to see whether there's a target down there. But if you can find this relatively undisturbed, and that means not in the accretionary prism, below the accretionary prism, and intact, you've got a chance of finding something really good. Of course, you might be in 3,000 or 4,000 meters of water when you do it. We know that it didn't go all the way to the north because we've got DSDP 543 and the two ODP wells, 1044 and 1046. They have Campanian marls sitting on oceanic crust, autochthonous oceanic crust. So we know it didn't go up there, at least in a point source. But where actually it did go, we're not really sure. So this is one of the great mysteries of this play, in this part of the play, away from French Guiana and Brazil, is where did this stuff go, and can you still do something in the play? So for part one, so we're going to hit part two, which is only a few seconds or a few minutes of slides. So in part one, we can be pretty confident that the fans have been drilled on both sides of the equatorial margin. And they do contain hydrocarbons, but commercial success has been a little elusive to date. Our understanding of the play has changed through time. Nevertheless, the basic play elements are grounded on proven concepts. It does work in some places. And when you consider all the risks, it can work really nice. The fan channel play might work on a technical and commercial basis in some geographies, while in others it's going to be very risky or likely it's not going to work on a commercial basis. And I think you've seen some examples where they might be riskier in some places than in other places. There are some fundamental differences in the play between the equatorial Atlantic margins and the central North Atlantic and the Caribbean that are going to negatively impact the chance of geologic success and the chance of commercial success in those areas. We've talked about them, structural complexity and a few things like that. So you sort of know where I'm going with this. And the play concept is valid. It may work for other geologic intervals. And I think more emphasis should really be given to the exploration for these kinds of things in other units, other age units. Pliocene to Eocene, those might work anywhere from Trinidad to Panama, although Panama's got its own problems. And someone was asking me about Northwest Colombia offshore, and indeed, that is one of the places that people are going to be trying to make this play. Whether it's an oil play out there or a gas play is anybody's guess. I certainly have my idea. Okay, so let's end with a summary or a review from 1970 to the present of exploration in the rock, the rest of Caribbean. So what you see on the map are a bunch of stars and a bunch of green circles. The green circles mean commercial oil or commercial hydrocarbons, at least in that. And the stars are places where it didn't work, non-commercial or dry holes. And you can see, by and large, that everywhere outside of Cuba, and I cheated a little bit with Belize, Spanish Lookout. It's not really a Caribbean thing, but it sort of is. Outside of those two, everything else is in the Southern Caribbean. And there are a lot of reasons for that. There's smart guys like Paul Mann and Jim Pindell that can tell you all you want to know about why that happens. I'm not going to go over it now. But suffice to say, that's the only place where it's really worked. And why? Well, a lot of these wells were drilled in the 1970s when play risk in terms of geologic concepts was not where it is right now. People weren't doing it in a quantitative way. Pete Rose wasn't doing it at that point in a quantitative way. So really, it was just done by the seat of the pants. Yeah, it's a big structure, we're going to drill it. And so the result is a circle of dry holes around the Caribbean. The application of technology was probably not what it is today. We didn't have a lot of the seismic attribute and ability, crunching ability that we do with modern processing to really see a lot of what we were drilling. Economics and price always play a role. Politics, as I was saying at dinner, play a huge role. Why? Well, I would love to go back to Venezuela. I'd love to do exploration there. I can't in any reasonable way for a lot of reasons, but Venezuela is a place that when it eventually does open up, everybody's going to flood back into because it's been frozen in time, essentially from an exploration point of view, since the end of the 1990s. And Cuba is another one. And you say, oh, there's nothing in Cuba. Well, guess what? There's commercial oil production in the carbonates, and that's sort of our tie back to the Cretaceous. There is some Cretaceous and Jurassic production onshore. But you see there's a couple of big stars there, one in the north offshore and one in the southern Bahamas, where it didn't work. Why is that? Well, let's take a quick look. So this is the Lease Map, courtesy of Jorge Piñon, an old Amico compadre, as of 2012. And you see in sort of the dark orange right there on the right, a whole bunch of leases held by Repsol at that time, and a bunch of other operators. If you'll recall, there was a big frenzy in the U.S. about people drilling wells in the Straits of Florida and what happens if there was a blowout and why aren't we doing it? And a whole bunch of things came out that were political hot potato at the time and people danced around. But effectively, there were only a few wells drilled, actually only 4. Repsol did drill a well in 2004 and they came back 2 years ago and drilled another well. A well was drilled by Petronas and another by PDVSA. And Sonangol right now is in theory, is shooting 3D over 2 blocks that they have, but that's the only activity that's going on right now. And what happened with these? You can see the number of leases has kind of shrunk a little bit. Well, those dry holes really discouraged people. And now, if you think about what was drilled, you can sort of understand it, because remember, whether we are looking at the Cretaceous play holistically as the fan channel system or any part thereof, there's something that still is a problem here, and that is that most of these wells, as you can see from these cross-sections that were produced by Coupet here going into the Straits of Florida, most of these wells were all drilled in a crush zone, and trap integrity and column height, and at least in this case, reservoir deliverability were key failure points. So does that mean that this isn't going to work anywhere? Well, no. It could work somewhere. I think I know where it could work, but I'm not going to tell everybody. Okay, the last thing that's worth talking about, which isn't Cretaceous, but it is recent activity. It's the only recent activity in the Caribbean recently, is the Paraíso well, which was drilled by Noble in Nicaragua. And it's notable because it was drilled in Nicaragua. I mean, you know, BG is doing some things in Honduras right now, which is quite adventurous, but nobody's drilled a well in Nicaragua for a very long time. And you gotta hand it to them. That's a pretty gutsy thing to do. At BP, we did some service work for the Honduran government, and we did some biomarker stuff on the main Cape oil, which is just in the north of that area across the Honduran border. You can see there's a lot of oil shows in those wells, and in fact, almost every one of those wells tests a valid structure. Yet there is no commercial discovery in any of those wells, even though there were follow-ups to a number of them. There is a reason for that. The reason specifically is due to charge focus, charge volume. This is what Noble drilled. This is their pre-drill look. They thought this was going to be pretty significant on an unrisked basis, 200 million to 1.2 billion barrels equivalent, and a 25% chance of geologic success. You can see the map there to the left shows a very large structural trend, certainly very valuable to drill and very worthwhile to drill. And there's the target, very well imaged seismically. You can see it's a tertiary carbonate complex on the top of an old high. It's really good. The only problem here with this system is charge, undercharge primarily. And that's really what the death of this play has been due to, at least in my opinion. So I guess you could say, was 25% chance of geologic success a fair assessment of risk in this play? I don't know. This is the post-well view, now without the seismic, showing that they still think the area has 2.8 billion barrels of unrisked resource potential. That's really a large number. It's quite a significant number. I don't know that I would agree with that. They see older targets and younger targets, and they say very importantly they are reassessing the geologic model for further prospects and leads, which I think is a good idea. Do I think this should have been drilled? Yeah, probably. Do I think the risk was a lot greater than what they're showing? Yeah, I think it probably was. But Noble's pretty good at drilling things that nobody else wants to drill, so I applaud them for taking the chance and coming out to do it. Probably once was enough. So the summary of the summary of the summary then is pretty simple. We know now from past experience that the Neogene section Trinidad has worked really, really well. The older rocks, Paleogene, Cretaceous, have not worked well. And we've seen why in some parts of the Caribbean, why they haven't worked well. And they're not likely to work well in most of the rest of the Caribbean, unfortunately. Doesn't mean that you can't do other things, but at least in this case, play risk assessments have either been incomplete or not fairly treated, I think, and they've been really the basis for some poor exploration decisions. So as I said in the previous sort of part one summary, there are some places where you can do these plays, but I think for Cretaceous deep water targets outside of the Gulf of Mexico and outside of northeastern South America, I think we're pretty limited in what we can do. If somebody wants to go out in deep water in Trinidad or between Trinidad and Barbados and do this, there's a chance you'll find it. It's really risky. It's going to be really expensive, but you could get the big reward. So with that, I will say thank you all for attending. I hope it was worth your while.
You want to take a few questions, Bob?
No?
Are there any questions for Bob?
Sure. Well, in the older rocks, it's difficult to know really what you're looking at anyway, whether there is going to be any AVO or not, just because of rock properties. The simple guiding principle is that if it looks too good to be true, it probably is. And even though the AVO showed really nice for some of these prospects, they were missing some key components, like understanding where the trap actually works, understanding whether there's charge to the target or not. And so in many cases, there are bed effects with thin bed shales that are producing exactly what they saw initially with some of the big discoveries. And that's taken wells actually to define. Didn't know that before they were drilled, but I think we we feel fairly comfortable with that now. I know that Scott and Wynn have seen plenty of this. Well, I can only go from, because I don't have data there, I rely on published information just like you do, and I can only go from what's been done recently. There have been a number of wells drilled in Morocco recently that haven't worked. They've been primarily for either lower Cretaceous or Jurassic targets, and for one reason or another, generally because of charge focus and or reservoir quality, they have failed. Doesn't mean that everything out there is going to fail, but the most recent wells, none of the recent wells have been successful. I think there have been 3 or 4 wells drilled in the play. Chevron's Gosh Turn rig is sitting in the Canary Islands right now. I think they're going to probably drill Repsol's target off the eastern part of the Canaries, between the Canary Islands and the Spanish Sahara. And that's a particularly interesting thing. I did field work there in the Canaries for BP years ago, and we mapped actually quite a lot of sand on shore that had the permeability of this microphone stand. It was the tightest stuff I had ever seen. We almost broke a hammer on it. Now, how that translates to the subsurface, I don't know. There's no question there's a ton of lower Cretaceous sand there, but I don't know if it's going to work. So they're going to take a flyer and see. Well, Gambia obviously is really interesting. From a conjugate margin point of view, it's sort of in a nice place with respect to what you see over on the Suriname side. And it's always been one of those things that's interested me. Guinea is another one of those. And it's compelling, it really is, provided that you've got a mature Cretaceous source. And I haven't done any work there, at least on source maturity. My big concern would be source maturity.
1960s.
Yes.
Never been produced.
Well, yeah, I'm trying to remember exactly what the name is. I can't remember, but that's been the target of recent deeper drilling that has not really worked out very well. The deeper targets haven't worked. The shallower target, which is where that is, in the upper Jurassic, has the oil. They did find it in the second well. I'm trying to remember who drilled it now, but I don't. But they never found it in the deep target, and that's really the key. We're so decoupled from the source that it's really difficult to charge some. Okay, so what do I think about Suriname in general, and what's the impact of the Demerara Plateau or the Demerara High? So Suriname in general, I'll try to sum up real quickly. I think it's got a lot going for it, but a lot of what it's got going for it is mostly in Guyana, and that's primarily from a thermal maturity point of view. Now, I like Block 47 because of the geometry of the canyon system. I think it's clearly got sand in it. It's clearly got source in it. We know that source exists from the ODP wells from Lake 207. So there's plenty of source. There's plenty of sand. The question is there a trap? And if you find it, can you produce it? That's the big issue right there. Further to the south, closer to Guyana, you have less of a problem with thermal maturity, but you have more of a problem with trap. And it doesn't seem like you would, but the North Coroney well, which was drilled on the Suriname side, looked like a wonderful thing to drill. It's got a great structure to it. There's no question that it looks like it should work. It didn't work, had some oil shows, because there was a direct connection between the shelf and the slope where the oil migrated up. So there was no trap. Now, when Repsol went down dip and drilled their well into the Paleocene, they ended up finding the same thing. They drilled one of the Paleocene fan systems and still had no trap, because it's been proven already from the wells on the shelf that there's so much sand in the system it came south. So the real issue I have there is it too sandy? Is there too much sand in the system to really form a good trap? Certainly we're going to see, because a lot of people have targets out there, and I'm certain we're going to see some more wells. So we've seen this big frenzy in West Africa. We're going to see it in the next 2 years in Guyana and Suriname. Now, as far as the Demerara Plateau goes, it's like Mount Rushmore. It's just a gigantic big thing, and it's a great sand source, but it's been drilled. The Exxon A21 well drilled that thing well into the Jurassic and had oil shows, but essentially it was a breached trap. So if you can find something you think is still intact as a trap, then you have a chance. But I wouldn't be looking for targets on top of the Demerara Plateau, even though there's a lot of licenses taken up there right now. Okay?
Okay, if you have some more questions, I'm sure Bob will be up here afterwards, I hope. In the meantime, oops, that says Francis Innes. In the meantime, Bob, I'd like to present you with this paperweight, which is Italian marble, I believe, and thank you very much for coming and speaking with us and taking the questions.
Thank you.
That concludes the meeting, and we hope